Hi there! Welcome to Science Made Simple by Ms. Floss. For today's standard, 62B.4, I can construct explanations for how climate is determined in an area, including latitude, elevation, shape of the land, and distance from water. Our cross-cutting concept, patterns, stability, and change. Before anything else, let us define first what is weather. Weather is the condition of the atmosphere at a specific time and place. For instance, you step outside your house and you notice that the sun or the condition outside is very warm and hot. So in that case, you will say the weather is sunny, or we have a sunny weather. But later during the day, you observe that it started to rain. So that in that particular time and place, you would say that you have a rainy weather. But when you say climate, it is an average atmosphere conditions over time. So we learned already what meteorologists are doing. So they gather data. They put that data into tables and graphs, and they look at patterns. So once they see already the average weather for that longer period, or for that, for example, for a year, and that is what you mean now by climate. So it is a collection of the different weather collected, look at the patterns, and observe which one happens the most in that particular time and area and place, then that is climate. So I have here different situations for you to practice on identifying if this situation refers to a climate or a weather. So you can do it for yourself now. Let's proceed. So there are different factors affecting climate, and one of those is latitude. Latitude is the measurement of the part of the Earth in relation to the north or south of the Earth's equator. Before anything else, remember that the Earth is actually tilted 23.5 degrees. So if this is the sunlight here, you will notice that this area here, especially the red ones, or what we call here the tropical zone, receives sunlight all year long. Whereas the temperate zone will just receive just enough sunlight, while the polar zone will receive less to no sunlight. So how are you going to identify which zone are there? So they call this, when you divide the Earth's surface into different parts, we call it now the latitude. So in this case, the one at the middle here, that's 0 degree, that is the equator. From 0 degree to 23.5, this is the Tropic of Cancer. And N here stands for north, is the tropical zone. From 23.5 degree north to 66.5 degree north, this part here has a temperate zone. And from 66.5 degrees north to 90 degrees north, they have the polar zone. And that goes also as you go down to the South Pole. So we have also tropical zone here, temperate zone, and the polar zone. So we have different zones here at a different latitude of the Earth, simply because the sunlight, here that can only reach those areas in the tropical zone, not much in the temperate zone, and less to no sunlight in the polar zone. So that is what you mean by latitude affecting our climate. So to apply that to our map in here, so you will notice that we are from this. So we are the North America. So if you go back to the latitude, where can we find North America in terms of the measurement of the surface or the part of the Earth? then we can say that we are located at the temperate zone. But I want you to look at where Miss Flamiano's country is. This is the Philippines, and it is found in between 0 to 20. So in that case, 0 to 20, we are in the tropical zone. So I want you now to think what could be or what will be Miss Flamiano's climate if we are located in this area. So that means we receive sunlight almost all year long. So when there's more sunlight, more evaporation, and more precipitation. And actually, right now, from our country, we are experiencing now a super typhoon or hurricane, just like hurricane here in the United States. But if you look at this area here, Antarctica. So Antarctica belongs to the polar zone. So if it's a polar zone, you will expect that the climate will be very cold. Second, another factor affecting climate is elevation. When we say elevation, that's the height above sea level. So if you look at this, if this is the sea here, from this point and to the topmost point of this mountain, we call it elevation. So we studied during the layers of the atmosphere topic that as you go up or as the altitude increases, the temperature will decrease. So in that case, you will notice that if you are living in an area that is having a higher elevation from the sea level, then expect that area to be having a colder climate as the one found at the sea level. So this area here will be colder than the one at the bottom. Another factor that affects climate is topography. Topography means the shape and features of land surfaces. So I want you to look closely to what's going on in this illustration. This is a liquid area. For example, this is a sea. And then you notice that if there's a sea here and there will be sun in this side, and then evaporation process will start to take place. So warm moist air will rise, and once it rises, it cools down and condenses, forming the clouds. When there's more clouds, precipitation will take place. So topography affects climate, and we have this windward side. That's a side where air is coming from and begins to rise over mountain. So this is the windward side where wind comes from. So in this side, you will notice that you'll have a wet climate simply because evaporation, because of the presence of water here, and condensation usually is taking place. The opposite of the windward side is the leeward side in here. This is the side where air is sinking. So air sinks, warms, and compresses. So this area here has a dry climate, simply because there's no body of water in here, and this is also where dry air advances coming from this area. So you will notice that this area will be like having a dry climate. So that's also what we say. When I was younger before, I was saying that, oh, simply because we don't have bodies of water, that's why this area is dry, or simply because like there's a mountain that stops the rotation of air, then that's the reason why the area opposite from this side here will always have a dry climate. So to explain further what's going on, just like in here, so we have the sea, warm moist air rises because of course there's a sun here, which is the driving force for evaporation. So once water evaporates, it reaches the higher altitude, cools down, and then forming clouds. but later on, precipitation will take place. The opposite of this area, you consider plants in here. So there are vegetation in here simply because of they have abundant precipitation. But look at the opposite of that, where there's dry air. So evaporation from compression and warming. So you will notice the difference of the plants that live and thrive in here as to the plants that live and thrive in this area. So dry air, so we can say that, oh, maybe this area will be a desert because of they have less precipitation because they don't have a body of water here. So if you don't have a body of water, so you don't have water that will evaporate, that will condense, and that will precipitate. So that is now what's going on in here. So a rain shadow effect can happen when wet air rises and falls on the ocean side of the mountain, creating a wet climate. So if you live in this area near the sea with the mountain here, so you will experience that you will have a wet climate if you live in this area. But in the other side, if you live in this area where the air moves down, this area is dry, and this creates a dry climate or a rain shadow. Alright? So now, another factor that affects climate is the unequal heating of land and water. Unequal heating of land and water. So one, we call it sea breeze. Is any wind that blows from a large body of water toward or into a land mass during the day. So sea breeze happens during the day. So what's going on? I want you to look at the land first. Land absorbs heat faster during the day, and they also cools down faster. That's the characteristics of the land in terms of its heating property. Whereas water, it heats up slower and it also cools down slower. So in that case, during the day when the sun rises up here, the land will absorb this heat coming from the sun, and that warms our land very fast. But for the water here, it takes time for the water to absorb heat. So that's why water heats up slower than the land. So during the day, you will notice the unequal heating of these two, the land and the sea, or the liquid part. So for example, maybe if this has already increases 10 degrees, still this one is not. So if you use a temperature, because we know temperature measures, thermometer measures the temperature, you will notice that this area is warmer than this area. So in that case, here, the cool sea breeze now will blow towards the land. So if you stand here, for instance, during the day, you will notice that the air coming from the sea is colder. That is what you call the sea breeze. Sea breeze again happens during the day when the cold air from the sea moves towards the land where the land is warmer. That is sea breeze. When you say land breeze, this happening during night, is blowing from land toward the sea, especially at night. So what happens now? The sun is out. So in that case, I said earlier that the land heats up faster, but they also cools down faster. In that case now, during the night, the land now is cooler. But at the sea, I said earlier, the sea heats up slower, and they also cools down slower. So in that case, if you If you feel cold and you wanted to go swimming, you will notice that the sea at night is quite warmer because